Questions 1 through 10 of the 1998 grade 10 Cayley math contest is what I will discuss in this video. So the first question states 0.3 squared plus 0.1 is equal to. Well, 0.3 squared is 0.09 plus 0.10, and this would be, of course, 0.19. So the answer is D. The pie chart shows a percentage breakdown of 1,000 votes in a student election. How many votes did Sue receive? Well, it looks like Jim received 20%, so 20% of 1,000, which is 200 votes. And Jane received 45% of the 1,000 votes, and that would be 450 votes. So the remaining votes is what Sue received. So you would just take 1,000 and subtract 200 and subtract 450. And that would give you 350 votes for Sue. So the answer here is B. The expression a to the 9th times a to the 15th over a to the 3rd is equal to, all right, a to the 9th times a to the 15th all over a to the 3. So if you remember, with exponents, if you're multiplying the bases, you add the exponent. So this would become a 9 plus 15, like that, and over a to the 3. So a 9 to the 15th is a 24, and then you have a to the power of 3. And then if you are dividing, you have to subtract the exponents. So this would become a 24 minus 3, and therefore this is a to the power of 21. So the answer here is E. The product of two positive integers p and q is equal to 100. What is the largest possible value of p plus q? Okay. This is sort of just a trial and error, I think. What they're asking for is two numbers that multiply to get 100. So if you do the prime factors of 100, there's quite a few of them. In fact, 2, 4, 5, 10, 20, 25, 50, 100 itself. And any of these numbers, if you choose two of them and multiply them, they will give you 100. So if I chose 5 and 20, it would give you 100. Not any two, but they have to match. Like, for example, if you chose 4, you choose 25. So what they're asking for is, if you do choose two numbers that multiply to 100, what is the sum of those numbers? So for example, in this case, it would be 5 plus 20, which is 25. Okay? Which is, by the way, one of the answers. What is the largest possible value of p plus q? Whenever you have questions that talk about largest or smallest, I immediately go to the extreme case scenario. And the extreme case scenario in this one is 1 and 100. So if you have 1 and you have 100 as p and q, that would indeed give you a product of 100. And therefore p plus q would be 1 plus 100, which is 101. So the answer here is B. In the diagram ABCD, it is a rectangle with DC equal to 12. If the area of triangle BDC is 30, what is the perimeter of the rectangle ABCD? Okay, so triangle BDC has an area of 30. And the area of a triangle is 1/2 base times height, so that's 30. So the base in this case of this triangle is 12, and the height is BC right there, and that's 30. So this would become 6h is 30, and therefore h is equal to 5. So h is 5. And now we can calculate the perimeter. Since this is a rectangle, this is also 5, and this is also 12. So the perimeter is going to be 12 plus 5 plus 12 plus 5, which is 24 plus 10, which is 34. So the answer here is A. If x is equal to 2, is the solution of this equation qx minus 3 is 11, the value of q is. So you have q times x minus 3 is equal to 11, and they've told you that x is equal to 2. So q times 2 minus 3 is equal to 11, and therefore 2q is going to be 11 plus 3. 2q is equal to 14, and therefore q is equal to 7. So the answer is B. In the diagram, AB is parallel to CD. What is the value of y? All right. So enlarge this a bit. This is parallel, and they've shown you that with these arrows. So since this is 70 degrees, this angle here is also 70 degrees. That's one of the properties when you have parallel lines. So the good news is that if you have a line and you have all the angles like that, the sum of those angles is 180. So x plus 70 is 180. 2x is equal to 110. X is equal to 55. So x is equal to 55 right there. And then if you look at this triangle right here in the middle, the sum of the angles is 180. So 55 plus 70 plus y is going to be 180. So solving for this, you get y is equal to 180 minus 55 minus 70, and that would be 55 for y. So the answer in this question is D. The vertices of a triangle have coordinates 1, 1, 7, 1, and 5, 3. What is the area of this triangle? So let's draw this out. We've got 1, 1, so approximately here. We've got 7, 1, so let's say here. We've got 5, 3, so approximately, let's say here. 5, 3. And we'll label the coordinates like that. And we've got a triangle that is formed by these coordinates. So the triangle looks like this. What is the area of this triangle? Okay, the first thing we need is a height. Anytime you want to calculate the area of a triangle, you need a height. So that will be our height perpendicular to the base. So the area is, of course, 1/2 base times height. The base is from here to here. Since this is 7 and this is 1, this is going to be 6. So the base is 6. The height is from here to here. Well, from here to here was 1, and from here to here, from the origin to this point, they've told you is 3. So that means the height is 2. So therefore this just becomes 6. So the area of this triangle is 6, which is answer C. The number in an unshaded square is obtained by adding the numbers connected to it from above. For example, the 11 is one such number. The value of x must be. All right. So first, let's draw out the square. All right, so I drew it a little bit bigger. It'll help us out. This is 5, this is 6, this is x. We've got 7, 11. So how did they get 11 again? They added those numbers 5 and 6. So similarly, in this box, you would have to add the two numbers that are above it. So that would be 6 plus x. In this box, you'd add the two numbers above, x plus 7, and just keep going like that. So in this box, it would be 11 plus 6 plus x, which is 17 plus x. In this box, it would be 6 plus x plus 7, which is 13 plus 2x. And finally, this box, they've told you, is 60. So to get 60, you'd have to add 17 plus x and 13 plus 2x. So 17 plus x plus 13 plus 2x is equal to 60. So we've got 30 plus 3x is equal to 60. 3x is equal to 30, and therefore x is equal to 10. So the answer here is E. The sum of the digits of a 5-digit positive integer is 2. A 5-digit integer cannot start with 0. The number of such integers is. All right, so we've got a 5-digit integer, and they're saying that the 5-digit integer cannot start with 0. Well, that makes sense, right? Because if you had 0 as the first number, and then you added some other numbers, it's no longer a 5-digit. It's a 4-digit. So this makes sense. So this is not possible. So what they're saying is you've got a 5-digit positive integer, and the digits, whatever they are, A, B, C, D, E, if you add them, they will total 2. Like that. So is this even possible? It doesn't seem like this can be likely. But as always, look at the extreme case scenario. So I'll start with one extreme case scenario, which is the number 10,000. It's a 5-digit number, and if you add up the individual digits, you get 1 plus 0 plus 0 plus 0 plus 0, which is a sum of 1. Now, does this satisfy our conditions? No, because they want the sum to be 2. Okay, that's not a problem. I can make that. How about this number? This is a 5-digit number, and the sum of the digits are 1 plus 0 plus 0 plus 0 plus 1. Sum is indeed equal to 2. So that definitely is one of our numbers. They want us to find how many of these types of numbers are there, where the sum of the digits is 2 and the number is a 5-digit number. All right, well, I can probably do a very similar number. This, of course, is another one. I can keep moving this one over. That's another one. And I can move it to that position. That gives you 4. Now let's see, what is the answers? This is 4. So it's not A, it's not B, it's not C. They've got 4, and they also got 5. Is there another one? Did I miss anything? And there's one more number, one more 5-digit number. It doesn't have ones in it. It has a 2 at the very beginning. And that has digits that have a sum of 2. So the total such numbers is 5. So that would be choice E.